Assalamu alaikum and good morning. Today, my team and I are gonna talk about differentiation. Here is the overview of our presentation. Our first point is stationary point and the second one is rate of change. Now, have you ever heard about differentiation? Differentiation is commonly used among businessmen to help marginal analysis. Differentiate help analyze marginal cost and marginal revenue, which determine the optimal production and pricing strategies for the firm. This will help them to prevent loss and etc. Rate of change commonly used in engineering. For an example, if you have a flat ball and you infuse it with air, you will the ball will expand, and that is the rate of change of the ball. Now, I will let my friend continue to explain more about stationary point and rate of change.
Okay, so I'm going to talk about stationary points. Stationary points are points on a curve where the gradient derivative is zero. These points are pivotal because they mark significant changes in the behavior of the function. At stationary points, the curve may exhibit various characteristics, including maximum or minimum values, or points of inflection where the curve changes concavity. We will see the next we will see the example in the next slide. Okay, so these are the examples of stationary points, which is minimum point, maximum point, and inflection. Now, let's assume the function is y equals 5 plus 4x minus x to the power of 2. In order to find the stationary points of the function, we first need to find its derivative and then solve for the points when the derivative equals 0. Using the power rule and the constant rule, we differentiate each term until we get dy over dx equals 4x minus 2x. Now, to find the stationary points, we set the derivative equal to 0 and solve for x, which is 2. Once we have found the value of x, we can find the corresponding y value by substituting x equals 2 into the original function, which will get y equals 9.
Okay, hi. So now I'm going to explain about rate of change. Rate of change are fundamentals in order to find the rate of change of area with respect to time. The rate of change describe how one quantity changes in relation to another. For example, if you are tracking the distance traveled by a car over time, the rate of change would be the speed of the car, which is how quickly the distance change over. Mathematically, you can find the rate of change by calculating the derivative of a function if you have a function that represent the relationship between two variables like distance and time. The derivative of the function tells you how the output variable, that means distance, change with respect to the input variables in time. Alternatively, if you have a set of data points, you can approximate the rate of change by finding the slope of a tangent line at a specific point on a graph. This gives you a measure how quickly the quantity is changing at a particular moment. Now, for an example, assume if a radius of circle increase at the rate of 5 centimeter per second, to find the rate which area is changed when the radius of the circle is centimeter. You have to do the next following steps. Alright, here the solution. Let's say R is length of radius and A is area. So, area equal to R power of 2. Given dr over dt equal 5 centimeter per second. Rate of change for area dA over dt equal dA over dt times dr over dt. So rate of change for area dA over dt equal to dA over dr times dr over dt equal to pi r of times 5, equal to 10 pi r. R equal to 10. dA over dt equal to 10 pi times 10. dA over dt equal to 100 times centimeter power of 2 per second.
The conclusion is, in summary, differentiate help us in identify critical points like stationary points and determine rates of change. For instance, in the function y equals 5 plus 4x minus x2, the stationary point is at 2, 9. Additionally, we can use differentiate to find how quantities change over time, as seen when we calculated the change of the area of a circle with respect to time when the radius increased at 5 cm and reached 10 cm.